In this video, I want to show that the infinite series with the expression 1 over 3 to the n times n plus 1, and that this infinite series converges to 3 times the natural log of 3/2 minus 1. And this video involves geometric power series. Once again, we want to show that this infinite series converges to 3 times the natural log of 3/2 minus 1. Recall that the power series representation for the function 1 over 1 minus x is the summation, is the infinite series with the expression x to the n. And this infinite series here converges when x is between -1 and 1. And also recall that we got the result, we got this representation by thinking of this infinite series here as a geometric series with the value of the first term is 1 and the common ratio r is x. And therefore this series right here, this infinite series with x to the n, converges to a over 1 minus r, and then a is 1, and so we get 1 over 1 minus x. And so this is how we got 1 over 1 minus x to be equal to the infinite series with the expression x to the n. And so now what I want to do here is to integrate both sides of this equation right here from 0 to 1/3. And why 1/3? The reason because the infinite series here involves 1 over 3, and so that's why I'm using 1/3. And so this is the same as 1 plus x squared plus x to the third, and so on. And so with this, the left side, and then we can use the substitution method to integrate this integral right here. So let u be 1 over x, 1 minus x, then du dx is -1. So we get dx to be -1 times du. And so our integral becomes 1 over u, and then dx is -1 du. And then recall that the integral of 1 over u is natural log of u. And then we have this negative right here. But u is 1 minus x, so we get -1, negative ln of 1 minus x. And then evaluate from 0 to 1/3. So when x is 1/3, we get 1 minus 1/3, which is 2/3. And then when x is 0, we get 1 minus 0. 1 minus 0 is 1, and natural log of 1 is 0. So we just end up with negative natural log of 2/3. And then we can rewrite this as the natural log of 2/3 to the -1. And then this is equal to the natural log of 3/2. The right side, here the integral, we get x, and then x squared over 2, x squared over x to the third over 3, x to the fourth over 4, and so on. And so using summation notation, we can write this as the sum from with the expression from x to the n plus 1 dividing by n plus 1. When n is 0, we get x. When n is 1, we get x squared over 2, and so on. And then evaluate from 0 to 1/3, and then x is 1/3. And then when x is 0, we just get 0. So this is what we end up with. And so now we get the natural log of 3/2 equal to the summation with the expression 1/3 to the n plus 1 dividing by n plus 1. So this is the result for the left side, and then this is the result for the right side. So the left side we get natural log of 3/2. The right side we get 1/3 to the n plus 1 dividing by n plus 1. And so we write this as so let's rewrite this. So when n is 0 for the top we get 1/3, and then for the bottom here we just get 1, so we get 1/3. So that's the first term. And then we can rewrite this summation here as 1/3 plus 1/3 to the n plus 1 times 1 over n plus 1. But now n starts at 1 because this term here is when n is 0. And then this summation here is the same thing as 1 over 3 to the n plus 1 times n plus 1. And then if we compare this summation, this series here with the infinite series that we're looking for, they're very similar. The only difference is instead of n here is n plus 1. So what we can do is multiply everything by 3 to get rid of this 1 right here. So first, let's go ahead and move the 1/3 to the left side, and then multiply each term by 3. So multiplied by 3, we get 3 times the natural log of 3/2. 1/3 times 3 is 1, and then 3 times the infinite series on the right side. And so this would be 3 times 1. 3 dividing by 3 to the n plus 1 is just 3 to the n. And then now we can see that this series right here looks exactly like what we're looking for. And therefore the series with the expression 1 over 3 to the n times n plus 1 is equal to 3 times the natural log of 3/2 minus 1, which is approximately 0.21639. And that's the end of the video.